So here is your review for the Module 3 Topic A test. No applause. Right. Yes. Okay. So there are going to be 10 questions on it. 7 of them are multiple choice. 3 of them are free response. For your multiple choice section, you should be able to simplify using properties of exponents. What do I mean by that? I mean exactly this. For example, if I have the expression 8xy to the negative fourth power divided by 2, the whole quantity, 2 to the x, 2 times x minus 2. I would want to be able to simplify that. How would I simplify that? First of all, I'm going to write that. I'm going to break it up. Break it up like there were 2 kids making out in the hall. You know what I'm saying? No, I didn't cut that out. All right. Please, on canvas, can you keep your talking your own mouth?
They don't know words.
Yeah. Okay.
Especially the ROTC kids.
So 8 divided by 2 is 4, and now I'm going to go x to the 1 minus negative 2. So this should become x to the positive 3 power. And then this y to the negative 4th power is, well, it's going to be, let's write it as 1 over y to the 4th. Right? Let's do that. Let's put it all back together, and we get that this is 4 x to the 3rd over y to the 4th. So also be able to use properties of radicals. This is a weird problem, so I'm going to do an example of it for you. I think I modified this from a part test, a release part test. So, really strange. First of all, don't try to say that the square root of a plus the square root of b is the square root of a plus b. So people might try to say that this would be that we could write those all under the same radical, right? We can't do that. It's really common for students to try to do that. Don't do it. All right? What you're going to do instead is use the idea that these can be factored. So this is the same thing as 6 times the square root of x times the square root of y times 3 minus, my bad, 3 times the square root of x. And it turns out that I have 2 terms here, right? 2 terms. Each one of these shares a common factor. 2 common factors, really, right? 6 and 3 share a common factor of 3. And a factor. And both of these terms also share the common factor of the square root of x. So I'm going to factor out the square root of 3 and the square root of x, okay? I'm going to factor that out. So 6 divided by 3 gives me the 2. The root x is gone, so I have the 2 square root y minus 1, right? If I divide negative 3 root x by positive 3 root x, it gives me a negative 1. Now, if I want to express that without any radicals, then I'll go ahead and change it and write that as 3x to the 1/2 times 2y to the 1/2 minus 1. It's a weird problem. But that's okay, because we all stay low. Okay, ready to go. Hey, also, in the multiple choice section, you're going to have to find the best approximation for 2 to some irrational exponent. The example I gave you is 2 to the e power, right? We've looked at 2 to the square root of 2 power. We've looked at 2 to the pi power as well, right? Very briefly, we looked at that. This is how you do it. First thing, step 1. Go ahead and calculate what that irrational number is. Alright? And then you're going to encompass 2 to that irrational power by 2 to the low end of, look at your ones place, right? And then the high end of your ones place. And then you just continually go out, right? It is definitely the case that E is between 2.7 and 2.8, right? Because all this other stuff in here is in between. In between 2.7. If you're thinking about it in terms of like a number line. That's kind of the way I envision these things. So as we get further and further out, decimal-wise, we wind up with a most precise approximation. Okay. Also, be able to perform operations using scientific notation and convert between standard form and scientific notation. All right. Easy peasy, I think, especially because it's multiple choice and you're allowed to use a calculator. So I don't really see that getting difficult. All right, so rate of change. We just did this. You're going to use that rate of change formula to model rate of change for a situation. So there are 2 questions using rate of change on your test. One is finding rate of change from a table of values. The other one is finding rate of change when given a function that models a certain situation. We're going to do the latter example right now. Okay? Let's check it out. So like I said, the first form is going to be from a table. And then also using a function. So an example of a function is, say we're talking about, I don't know, bacteria growing. That doesn't creep out germ clothes. Growing on you right now. So here's our example. Bacteria growth. It's modeled using the function f of x equals 3 to the x power plus 2, where x is the elapsed time in hours, and f of x is the number of bacteria in thousands. We're going to find and interpret the rate of change from 5 hours to 10 hours. How shall we do this? Using our rate of change formula. So,
Oh, that's right.
there's our function. There's our formula. We're going to look at it from 5 hours to 10 hours, right? And so in other words, A is 5 and B is 10, right? Then f of B is f of 10. So that's 10 to the, my bad, 3 to the 10th power. which is something. It is 59,000. And 51. And then f of 5 is 3 to the 5th power plus 2, which is 245. And so now if I plug that into my my rate of change equation, that's going to be equal to 59,051 minus 245 over B minus A. What is it? 11,761.2. What is that though? It's thousands, right? And it's thousands bacteria, right? All right. So we can write that as. So then, if we put that in context, right? We could say that the rate of change between 10 and, or between 5 and 10, or let's do that in sequence 5 and 10 powers is, let's go count. 11,761,200 bacteria per hour. And thus we have done it. We have answered this question. Hart loves these types of questions. You know who's going to be ready for them? You are. All right, let's check it out. What's next? All right. So I'm going to write this one without radicals. First thing I'm going to do is I'm going to write it as the square root of x minus 3 to the 1/6 power, right? I can do that. And then I'll go further, and I can write this as x minus 3 to the 1/2 power to the 1/6. And then I can multiply those exponents, so this becomes x minus 3 to the 1/12 power. Hey, what if I wanted to put it back in a radical form? So as a radical, I would write that as the 12th root of x minus 3. All right, and the next one. Hey, what if I needed to simplify this without radicals or negative exponents? Well, what I'm going to do is first work out what is inside of my radical. Because it's what's inside that counts. It is what's inside that counts to these girls. What's inside your wallet? What's inside your bank account? So, 36 divided by 3 is 96. Sorry, it's 32. And then I'm going to subtract these exponents, so this becomes x to the 8 minus 2, or 6. And then y to the 8 minus negative 2, which is to the 10. Okay? So then I want to break up this party. I'll write it like that. And now I put these bad boys into rational exponent form. What is the fifth root of 32? 2. Sweet. And then I can write this as x to the 6/5 power. And I can write this as y to the 10/5 power. Darn it, I have one more step, and that is to simplify that fraction in the exponent for y, which makes that y squared. There we go. Done. All right. That is all. That's what we're here.